To start the identification of the unknown structure, we will start with the MS spectrum. First, identify the M plus peak located at 150. Next, identify the base peak at 105. We then subtracted 150 to 105 to get M minus 45. Next, we use the formula 2 times the number of C's plus 2 plus the number of N's minus the number of halogens minus the number of hydrogens, all divided by 2, to calculate the degree of unsaturation. Our DOU equaled 5. Additionally, the MS shows no chlorine, nitrogen, bromine, and fluorine. Next, we will look at the IR spectra, which contains 5 different zones. Zone 1 from 3200 to 3007. Zone 2 from 2700 to 3200. Zone 3 from 2000 to 2300. Zone 4 from 1650 to 1850. And then Zone 5 from 1450 to 1680. In our IR spectrum, only Zone 2 and 4 have any relative data. At about 3000, a large peak is present. It looks to be about an sp3 orbital. At about 1725, a peak seems to indicate a C double bond to O. Next, we will examine the HNMR. Based on our data, it looks to be 3 or 4 different environments. At 1.5, there is a triplet with an integration of 3. At about 4.5, there is a quadlet that can be seen and an integration of 2. And finally, at 7.5 to 8, it looks like a set of peaks with an integration of 5. Based on this information and the chemical formula from the mass spec, we can now suggest a possible structure. Because the DOU was 5, we can suggest that there is an aromatic ring. Connected to the aromatic ring is an ester, and then the oxygen on the ester is connected to an ethyl chain. Next, we'll add in the hydrogens in the structure so we can match the different environments on the structure to the HNMR spectrum. Okay, so first we'll look at the hydrogens on the benzene ring. We match that up with the peaks with the 5 integrations because there are 5 different hydrogens in that one environment. Okay, next we're going to look at the middle section of hydrogen. For this, we're going to do the N+1 rule. So N+1, it looks like N is going to be 3 because it can see 3 different hydrogens. So N+1 is 4. That is going to equal the 4 peaks. And there are 2 hydrogens, so 2 integrations. So that peak matches that environment of hydrogen. So that leaves the last peak to match the last set of hydrogens, because there's 3 hydrogens and then there's 3 integrations. Finally, the CNMR dataset can be examined to confirm the previously suggested structure. The peak at 168 is relative to the ester. The next set of peaks, which is at 130, could be correlated to the aromatic ring. The peak at 60 could be the carbon closest to the oxygen. And the peak at 18 is the carbon at the end of the ethyl. This confirms that our suggested structure is correct. Thank you for your time.